Hello everyone, welcome to Intellect Instruct. So this is the part 2 of important questions of digital signal processing. All 5 modules are covered in this video. In the part 1 of the important questions, only module 1 was covered. So in this video, all 5 modules are covered. So let us go to module 1, important question. So in module 1, the importance are the sampling, 4-point DTFT, properties of DFT derivation, problems are on circular convolution very important, and the endpoint DFT and the 4-point circular convolution. So all these questions are taken from model papers as well as repeated questions. Then let us go to the module 2. Here also the importance are overlap, add method, overlap, save method, radix 2 algorithm, 8-point DIT FFT, then a DIT FFT algorithm, computational complexity, radix 2 DIT FFT algorithm with signal flow graph, and the FIR filter with impulse response, then the radix 2 decimation in frequency, procedure for overlap, add and save method, bit reverse addresses, multiplications, additions, fiddle factors, efficiencies, finding DFT and IDFT problems, find the convolution using Stockham's method. Then let's go to module 3. So here also design of analog Butterworth filters, direct form 1 and direct form 2 are important. Design of digital filters using analog Butterworth. Then Butterworth order derivation, FIR lattice structures. Fourth module is also similar to this. Differences between IIR and FIR filters, design procedure for FIR filter, cascade form, direct form, lattice structures, realizing using direct form 1 and direct form 2, same the low pass filter, high pass filter problems. Here are the examples. All the sequences and the values given in this are just for example purpose. For the questions PDF, you can just take the screenshots or you can mail me. I can send you. Next, let's go to module 5 questions. So in module 5, the important questions are Harvard architecture, neat diagram explanation, and MAC, that is multiplier and accumulator, shifters, address generators, IEEE single and double precision format explanation. Also the basic architecture of TMS3 to 0C54X family GS processor, and conversion of decimal numbers into Q15 representation. It's also very important, and also the fixed point and floating point and difference between Harvard architecture and von Neumann architecture. So if you like the video, please like, share, and subscribe. Also, all the best for your exams, and please study all these questions. Okay, all are very important.